Now, fertilization and fetal development becomes a very important topic, which of course forms a foundation to other topics that may be of use to each one of us. Topics, for example, to do with pregnancy. Now, the term fertilization is defined as the process by which the male and the female gametes unite to form a fertilized cell called the zygote, leading to the development of a new individual. This is coming from Sellers. The edition is 2010. Now, the male and the female gametes are the sperm and the ovum, respectively. So the first thing that will be created after the uniting of the male and the female gametes, it's the zygote. And we know that from the zygote, we'll have the embryo, then we'll have the fetus. That's the progression. For the sake of remembering, it's ZEF, ZEF. So once the ovum has been released by the ovary, it is propelled into the fallopian tube, okay? And this is aided by the action of the cilia. These are air-like structures which will be waffling, moving in one direction, and by that, they are pushing the ovum forwards. And apart from that one, we'll have the peristaltic muscular contractions of the fallopian tube itself. And fertilization takes place in an area or a component of the fallopian tube called the ampulla. Now, this fertilization can be internal, external, and in vitro. For this discussion, we'll focus on internal fertilization, which is occurring inside the fallopian tube after the female and the male gametes have met. Then key to this topic are definitions. And the first definition has to do with the amniotic fluid, which at time it's called the lycoamni. And this is basically a clear pale straw colored alkaline fluid, which fills the amniotic sac. This is where this fetus or the zygote will start developing from. The second definition, it's the blastocyst. And this is basically a fluid-filled cavity which appears in the morula as it is formed after the 4th day of fertilization. The suture, this is the name of the uterine lining or the endometrium once a woman has fallen pregnant, that is the suture. Then apart from this, we have the morula. This is an early stage of development of the ovum. And usually this is when it is a solid mass of cells. Ovum, this is a reproductive cell of the female, or this is the female gamete. Placenta, this is just a vesicular structure inside this pregnant mother, usually found on the suture, which is a good connection between the developing individual, the fetus, and the mother. Fertilization is basically the union of the male and the female gametes to form a fertilized ovum. This is a demonstration of the two gametes. We have the sperm and we have the ovum. It's interesting to take note of the structure, especially of the sperm. It has the head, the middle piece, and the tail. This will be very important as we continue. Then on the ovum, the layers that are enclosing the ovum of particular importance is the zona pellucida, and we also see another area, which is the corona radiata, which is the outer part. So the zona pellucida is inside, then we have the corona radiata outside. Then apart from this, fertilization, as we earlier indicated, occurs in the ampulla of the fallopian tube. Now, it's important to take note that at ovulation, the fimbriae of the fallopian tubes approach the ovary. The fimbriae, these are structures that are attached at the terminal end of the fallopian tube. So they will approach the ovary and draw the ovum into its lumen. Now, this is the lumen of the fallopian tube. Then, from there, we see the progression or the movement of the ovum, okay? And I earlier on said this is aided by the sweeping movement of the cilia and partly by the peristaltic movements of the muscular fallopian tubes. Then it's also important to take note that the amount of the male gametes or the sperm which are deposited into the female vagina during intercourse, they're about 300 million. And only a smaller portion, between 1,000 to 3,000 sperms reach the ovum, okay? Now, these sperms, usually they will propel themselves by the lashing movement of the tail, as it was demonstrated in the picture, and they will usually move in a forward direction, okay? Now, out of the 3 million sperms, a good number are destroyed by the acidity of the vaginal fluid. Wow. Some may fail to reach the uterus because they cannot swim against the fluid current. Then those that reach the fallopian tubes retain their fertilizing ability for at least 3 days. That is why when one has had unprotected sex, the duration in which they can take tablets that can prevent pregnancy, usually the allowed period is 3 days. So the mature sperm, the spermatozoon that encounter the ovum, produces an enzyme called hyaluronidase. So this enzyme breaks down the protective protoplasm of the ovum. The ovum has a protection around itself. So the sperm will produce an enzyme to help it penetrate the ovum. And the name of the enzyme is hyaluronidase, which is very important to take note. It breaks down the corona radiata. This is the outermost layer of the ovum, the corona radiata. And after it has been broken down, it will facilitate the penetration of the zona pellucida. So the zona pellucida is the lining which is inner, and the corona radiata is the outermost layer of the ovum. And it should be of interest to each one of us that only one sperm will penetrate the ovum. So as soon as contact between the sperm head is established, the two cells clamp together and the cell membrane is sealed. So meaning not at any time should two sperms fertilize one ovum. It's only one sperm fertilizing an ovum. When that has been reached, what happens? The ovum seals off, meaning no any other sperm can fertilize it any further. Now, it's important to take note, as Sarah has indicated, the body and the tail of the sperm separate from the head as soon as access to the ovum has been gained. So this is additional information. Now, this is what we're just trying to analyze. So what we are seeing, it's the outer layer, and this outer layer, it's the one that we are referring to as the corona radiata. Then the inner layer is the one that we are referring to as the zona pellucida. So the enzyme that will be produced by the sperm will ensure that it breaks down these layers so that penetration of the sperm is easier. Now, let's go through the development of a fertilized ovum. The zygote, which is the fertilized ovum, continues its journey. This is after fertilization. And this journey is carried along the fallopian tube and reaches the uterus 3 or 4 days later, which is approximately 72 hours. Now, during this time, cell division takes place and the fertilized ovum divides in two cells, 4 cells, 8 cells, and then 16 until anyway a cluster of cells is formed. And what will be formed after the division has reached 16 is what will be known as a morula. Okay, just a mass of aggregated cells. Now, this cell division is called mitosis, and it occurs slowly about once every 12 hours. A morula is produced by the continuous reproduction of the zygote, the same divisions that we were looking at, until it resembles a belly. That's why it's called a morula. This division is aided by the progesterone from the corpus luteum. The corpus luteum, it's the structure that will remain when the ovum has been released, which is also known as the yellow body. So this division will be aided by the progesterone that is produced from the corpus luteum with the estrogen, okay? And this usually facilitates the preparation of the endometrium to receive the fertilized ovum. Remember, during menstruation, estrogen will be so much used in building up the inner lining, the nourishing of the endometrium, so that when this implantation has occurred, we'll have a situation where the developing ovum will have nourishment. Okay. Now, furthermore, this is just the corpus luteum. I think the diagram is not clear, but this is the corpus luteum, which produces progesterone. Okay. The morula is contained within the zona pellucida rather like an egg in a shell supported by its own cytoplasm, which contains progesterone. So after 6 to 7 days after fertilization, the developing morula comes to lie adjacent to the endometrium, which is in its secretory phase. So this is very important. During the menstrual cycle or menstruation, there are those phases. There's secretory phase, we have the menstrual phase, we have a phase that is proliferative in nature. So the duration or the phase in which this morula, which has undergone mitosis, and I think it has now 16 cells, it will lie adjacent to the endometrium. So this is ready for implantation. Okay, it begins to embed by means of its own invasive properties. So this is the morula, which interact with the sticky surface of the uterine lining. Now, by the end of the first week, some inner cells in the morula begin to disintegrate, leaving a cavity. And this cavity is filled with a fluid. So this cavity is what is now known as a blastocyst, okay? And usually this blastocyst will consist of the following. One, the inner cell mass. And it's important to take note that this inner cell mass will develop to form the fetus, okay? The placental membrane, also known as the amnion, and the umbilical cord. A repetition, the inner cell mass will develop to form the fetus, the placental membrane, also known as the amnion, and the umbilical cord. Secondly, this structure, which we're referring to as a blastocyst, also have another component called the trophoblast. This is where the placenta is formed, okay? So now embedding of the placenta on the lining of the endometrium, which now we are calling as the suture, is known as nidation. Nidation can also be referred to as nesting. And this is normally complete by the 11th day after ovulation. And the endometrium crosses over it completely. So it's an interesting scenario which we are trying to actually look through. So how does the embryo develop? Now, this description of the embryonic development is based on a smaller book called Verus. The edition is 1993. So let's go through. So firstly, we have the suture. This is the endometrium during pregnancy, as I have already indicated. Now, the increase in estrogen in pregnancy leads to the growth of the endometrium to 4 times its non-pregnancy thickness. This is very important because there is need of nutrition, there is need of adequate supply of oxygen fluids to this developing embryo. So the progression, once fertilization has occurred, the first structure that is created or formed is known as the zygote. From the zygote, we have the embryo. So now we are just trying to describe this. The corpus luteum, we are of course aware that produces large amounts of progesterone, okay, which stimulates the secretory activity of the endometrial glands and increase the size of the blood vessels, meaning at this stage there will be tortuousness that will be achieved. This accounts for the soft vesicular spongy bed in which the fertilized ovum implants. So the fertilized ovum is lying in a very rich environment, okay? Now, layers of the desuger, which is the endometrium as we already looking at it. There are 3 distinctive layers of the desuger. Number 1, we have the basal layer. Now, this lies immediately above the myometrium. The myometrium is the middle layer of the uterus and is composed mainly of muscles, okay? So lies immediately above the myometrium. This is the basal layer. It remains unchanged in itself, but regenerates the new endometrium during puerperium, okay? Once we have the delivery of a viable baby. This is the layer that is called the basal layer of the endometrium in the non-pregnant state. Very important to take note. Let's move on a bit further. The other layer is called the sponge layer of the desuger, which is the functional layer. It is also called a functional layer because it's where we have the tortuous glands, which are rich in secretions, okay? So very important for us to take note. The stroma, which is the broad band of connective tissues, or the stroma cells are enlarged and in what is known as the desuger reaction. The cells are loosely knitted together with large spaces in between the groups of cells. This is important because we need the complete embedding of this ovum into the endometrium. Important, I think, to take note. The other layer that is important to take note is the compact layer. This is the first layer that the ovum encounters when it enters the uterine cavity. And this layer is continuous with the lining of the uterine tubes, the fallopian tubes. So all in all, there are 3. We have the compact layer on top, then functional layer, then underneath we have the basal layer. Compact layer, this one is continuous with the uterine or the fallopian tubes, okay? Let's go to the inner cell mass. Let's go to the inner cell mass. So while we'll have the medulla, which developed into the cytoblast, now we have the trophoblast. So while the trophoblast is developing into the placenta, which will now nourish the fetus, the inner cell mass is forming the fetus itself, okay? So it's very important. The inner cell mass, that's where we are seeing the fetus developing from. The cells themselves differentiate into 3 layers, each of which form a particular part of the fetus. Let's begin with the ectoderm. So the ectoderm, which is a part of the inner cell mass, mainly forms the skin, okay? The skin, this skin, which we're able to see, the skin and the nervous system. So ectoderm is equal to the skin and the nervous system, okay? Then the mesoderm, which is another layer of the inner cell mass, forms the bones and muscles, okay? And also it forms the heart and the blood vessels, including those that are in the placenta. So important. Certain internal organs also originate from the mesoderm. The endoderm form the mucous membranes and glands, right? So the 3 layers together are known as the embryonic plate. What is known as the embryonic plate? The endoderm, the mesoderm, and the first one, which we're referring to as the ectoderm. These are parts of the inner cell mass. So the inner cell mass, it's where the fetus is developing from, which is subdivided into 3 layers. So each layer is responsible for a particular structure of this fetus. Ectoderm, the skin, the nervous system. Okay. Then the mesoderm, the bones, the muscles, blood vessels, the heart itself, and apart from that one, certain internal organs. The endoderm, the mucous membranes, and the glands. Combining these layers, we are forming what is known as the embryonic plate. Okay, 2 cavities appear in the inner cell mass. One is on either side of the embryonic plate. The first cavity is the amniotic cavity, and the second is what is known as the yolk sac. Okay, let's start with the amniotic cavity. So the amniotic cavity lies on the side of the ectoderm, and the cavity is filled with a fluid gradually, which enlarges and folds around embryon to enclose it. Now, the amniotic forms from its lining, the amniotic fluid, it will form from its lining. It swells out in the chorionic cavity. The yolk sac is the one that lies on the side of the endoderm and provides nourishment for the embryo until the trophoblast is sufficiently developed to take over. Part of it contributes to the formation of the primitive gut, the gastrointestinal tract, the primitive one. Very important to take note. Okay. Now, in addition to what we are currently discussing, it's also very important that we discuss of the placenta. What is the placenta? What is its use in this regard? So this is an organ that originates from the trophoblastic layer of the fertilized ovum. It links closely with the mother's circulation to carry out functions which the fetus is unable to perform for itself during the intrauterine life. Survival of the fetus, therefore, depends entirely on the placenta. However, it's very important that as health workers, we need to take care of these women during their pregnancy. That's why they are subjected, for example, in our area, Zambia, they are subjected to these treatments, for example, for malaria. Or what we want is to improve on the integrity of the placenta. So the integrity and efficiency of the placenta is so critical, it's so nice that we need to ensure that it is not compromised at any time. Now, the development of the placenta is usually embedded with the trophoblast. This is where the placenta is formed, and the remainder of the chorionic villi, which will atrophy to form the chorionic membrane, which surrounds the amniotic sac and lines the uterus. So it is something that can be well understood when we go through notes again, which will be shared. So the trophoblast, this is where the placenta is formed, okay? And it's very important for us to take note. Then apart from this, it's very important to take note that the placenta is completely formed and functional from 10 weeks after fertilization. So 10 weeks translates in 2 months, 2 weeks. So the placenta will be functional. In its early stages, it's relatively a loose structure, but becomes more compact as it matures between 12 and 20 weeks of gestation, right? The fetal blood, which is low in oxygen, is pumped by the fetal heart toward the placenta. So the placenta itself really works in a marvelous way. It will be a link between the developing embryo fetus and the mother. So circulation of deoxygenated blood, the supply of nutrients, and the excretion of waste products from the fetus will occur around this area, which is known as the placenta itself. Then it's also very important to note that without the viability and the efficiency, top-notch integrity of the placenta, compromise can be noted, and what we are discussing may not just occur. Okay. Now, the maternal blood is delivered to the placental bed in the desuger. Remember, the desuger, it's the term of the endometrium once one has fallen pregnant. So the maternal blood is delivered to the placental bed in the desuger by the spiral arteries and flows into the blood spaces surrounding the villi. It is thought that the direction of flow is similar to a fountain. The blood passes upwards and bursts the villi as it circulates around it and drains back into the branch of the uterine vein. So we are seeing supply of blood to the placenta, which ultimately will be supply of blood to the fetus. By the way, let's take note. Not at any time does blood of the mother and the blood of the fetus mix. Okay, there is no mixture at any time. Now, the placenta, usually at a term, its situation is normally situated in the upper uterine segment. Okay, anything that will bring this placenta to be implanted on the lower uterine segment will just translate into a complicated pregnancy. So the placenta is situated in the upper uterine segment. It's flat, roughly circular structure, approximately 20 centimeters in diameter. And apart from this, it's also very important to take note that the placenta itself is 2 to 2.5 centimeters thick in the center, but gets thinner toward the circumference. The weight is approximately 500 grams, or is 1/6 of the baby's birth weight. So this is important to note in this regard. Questions can be posed later, but we can move a bit more. So that's the mature placenta. The surfaces of the placenta, there are two. We have the maternal surface and we have the fetal surface. The maternal surface blood gives this surface a dark red color. Okay, part of the basal desuger will have been separated with it. So the surface is arranged in about 16 to 20 lobes or cotyledons. And it's important when you are doing examination of the placenta to count these lobes. If the lobes are less, meaning they are retained in the uterus after delivery. And this is what can lead to overbleeding because the uterus cannot contract in any way. So the surface is arranged in about 16 to 20 lobes or cotyledons, which are separated by grooves or sulci, and these are furrows into which the desuger dips down to form walls or septors. So it's interesting, I think, to have time to check through the pictures for the lobes themselves. Then we have the fetal surface. So the fetal surface is the surface of the placenta that is facing the fetus. Maternal surface faces the mother, okay? So under the fetal surface, we're being told that the amnion covering the fetal surface of the placenta gives it a white, shiny appearance, okay? And we should also be aware that the membrane that's around the fetus are two. We have the chorion and the amnion, okay? It's important, I think, to know that. So parts of the placenta, there are two. We have the maternal surface and we have the fetal surface. So this is a pictorial representation of what we are trying to discover. The one on top, it's the fetal surface. Then the one beneath, it is the maternal surface. It's the one that is attached to the uterine walls. Then the one that is on top, it's the one that is in contact with the fetus, and therefore we have a shiny surface. The other one is darkish in color. The shininess is as a result of the amnion. Okay, I think this has already been described. Let's go through the two membranes. We have the chorion. This is the thick, opaque, friable membrane derived from the trophoblast. Okay, it is continuous with the chorionic plate, which form the base of the placenta. So that's the first one. We have the chorion. The amnion, this is the smooth, tough, thin, translucent membrane derived from the inner cell mass. It has a role in the formation of the amniotic fluid. So the one that is inside is the amnion. The one that is outside is the chorion. So we need to take note of that. Okay, let's continue. The umbilical cord. The umbilical cord or funnel extends from the fetus to the placenta, and it transmits the umbilical blood vessels, 2 arteries and 1 vein. And it's very important, again, when you are doing an examination after the delivery of the baby, you can check around and see these blood vessels. So there are 3 of them. We have 2 arteries and 1 vein. So these are enclosed and protected by Wharton's jelly, which is just a gelatinous substance formed from the mesoderm. The whole cord, which is the umbilical cord, is covered in the layer of amnion and continuous with that covering the placenta. Okay. The source of the amniotic fluid is thought to be both fetal and maternal. It is secreted by the amnion, especially that which covers the placenta and the umbilical cord. Okay, so that's the fluid where the baby is. Now, some fluid is exuded from maternal vessels in the dosuger and some from fetal vessels in the placenta. So these are sources of this fluid. It can either come from the blood vessels of the mother or from the blood vessels of the placenta. Now, apart from there, ultimately, the amnion itself, the inner layer, is critical in the production of the amniotic fluid. Now, the fetal urine also contributes to the volume from the 10th week of gestation onward, meaning when the fetus is urinating in utero, it will contribute massively to the volume of the amniotic fluid. And by the way, the urine is sterile at this time. The amount of the amniotic fluid increases throughout pregnancy until about 38 weeks of gestation, when there is about a liter. It then diminishes slightly until term, when approximately 800 mL remain. If the total amount exceeds 1,500 mL or 1.5 liters, then a condition known as polyhydramnios is ensued. Now, poly means plenty, okay? Poly, P-O-L-Y, polyhydramnios. So it's a situation where we have more than enough amniotic fluid. If less than 300 mL, the condition turns upside down, and this is known as oligohydramnios. So it's important, I think, to know that. Now, these conditions are often associated with congenital malformations of the fetus. It's interesting to note that the normal fetus swallows the amniotic fluid, but if anything interferes with the swallowing, then the excessive amount of the amniotic fluid will be seen. Similarly, if the fetus is unable to pass urine, the amount of fluid will be reduced. Okay, so very important. What constitutes the amniotic fluid? It's important to take note that 99% of it is water. The remaining 1%, it's all about dissolved solid matter, including food substances and waste products. In addition, the fetus shed the skin cells, the venous castosa and the lanugo, in the fluid itself. So it is a fluid where this baby is also bathing through during the time of its presence in the uterus. What are the functions of the placenta? Well, number 1, respiration. Number 2, nutrition. Number 3, excretion, storage, and also as a protection. So these are very important. Apart from that, it also acts as an enzyme, okay, It also acts as an enzyme, and it is necessary for the synthesis of proteins and also for the synthesis of respiratory enzymes. Okay, so it's very important. Apart from that, it also play a critical role as an endocrine function. And this is through the production of the hormone known as human chorionic gonadotrophic hormone. This is a hormone that is responsible in the maintenance of pregnancy. Progesterone can also be produced by the placenta from the 12th week, and the amount may rise as the pregnancy continues. Estrogen can also be produced between the 6th to the 12th week. Okay, so this is very important. Apart from that one, we have another hormone that is known as the human placental lactogen. So the human placental lactogen is also produced from the placenta. The Diraxin is another thing that can also be produced. It's a hormone that is very important. And I think for now, we can